we had to draw the isomers of octane, what that would mean, okay, is we don't want to do this. Okay, because if we're drawing an isomer of that, why is that incorrect? I mean, you got the right idea, but that's still octane. Okay, so that's what I'm getting at. Okay, so one of the aspects is we can't do this either. Okay. No. Why? Now you got 9 carbons in there. Okay? Because remember, when you think about the true definition of an isomer says what? It's the same what? Same molecular formula, which if we still had just this straight chain here, okay, we know that it's C8, okay, H18, okay. So when you do that and you put this, yeah, that's still octane, I get that, but now you've got 3-methyl octane, which means now you've got that. So that can't be an isomer, even though your parent chain is still octane. Does that make sense then? Okay. So what you have to do then is from octane is change it to a hexane molecule. You could do, what else could you possibly do? You can change to a pentane, but you're making it maybe a little more difficult than what you have to. What else could you do for that? Rather than octane, we went 3 down and 2 down. How about we just go 1 down? In number, I mean. Go 1 down in number. Now your parent chain is what? Heptane, and then, but don't do this. Okay? Why don't we want you to do that? That's still, yeah, that's still heptane. Okay? So one of the things you could do, okay? 2-methylheptane, what else could you do? 3-methylheptane is an isomer. Heck, we can even keep on going. 4-methylheptane. Okay? So once we run out of that, okay, so we could go 4, but we can't go any further because then we're back to 3-methylheptane. Okay? So if we take 2 carbons off, okay, there's a whole variety of different combinations we could come up with. Could you put an ethyl group on there? Sure, we could do that right here. Okay, notice that from our first compound, these isomers of octane was this formula. Does this still have a molecular formula the same as this? I bet it does. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. C8. All right. And then we should have 18 hydrogens. 3, 5, 7, 8, 10, 13, 15, and 3 more gives you 18. Okay. So that's also an isomer. So it's got the same molecular formula as octane, but it's a different structure. Okay. Yes, because if you notice you have it on the 3rd one here, well, what happens if I do that now? It's still the same thing. Okay? And another aspect you could possibly think you're putting an ethyl group on is doing this. Okay? it's still heptane. It's 3-methylheptane. Okay, so those are just some common mistakes that I that stuck out in my mind. Okay. Is there anything that might be unclear for yourselves? Probably the biggest aspect on the multiple choice questions would state something like, within a compound, if there is a double bonded oxygen on the first or end carbon, the functional family is this. Is it A, an aldehyde? B, is it a ketone? C, is it an acid? Or D, is it an ester? Okay, so look at what the wordage says. If there is a double bonded oxygen on the first or end carbon, the functional family is called which one of those selections? It is an aldehyde. So just keep this in mind. There's nothing wrong with writing whether it's 3 carbons or even just 2. You can do that, but it's maybe easier to see with 3. Okay, because we had said if there's a double bonded oxygen located on the first or end carbon, well then we know that this compound then, the functional family, is an aldehyde. Okay, how could we change that to an acid then? We don't need to erase anything. We just put an OH on here. Now we would say we've got an acid. Okay? Can we change that to a ketone? Sure, but we got to get rid of this. And what do we got to do with that double bonded oxygen? Yeah, move it to the middle. There it is. Now we've got your ketone, because the double bonded oxygen is not on the ends. Okay? Do you feel comfortable with those organic families, or do you want to go over them still? Because I know you were busy tonight. I want to give you the maximum amount of time with what you feel comfortable with. But here, go ahead and hand these back to you. Okay? Easy mistakes to fix. I mean, because we always say the same thing about mistakes. 1, let's try not to repeat them. 2, try to learn from them. Okay? So some maybe alphabetizing or the isomers. Okay? It's nothing absolutely critical. So, with that, and then the only other aspect, your vocab, but we went over those yesterday. The question could state, what is a tertiary butyl structure? Well then, you'd have to look in. Okay, is that a tertiary butyl? Is that a tertiary butyl? So which one of those is a tertiary butyl? Yep, this is T-butyl. This one is isobutyl. This one is just plain butyl. And it might just say that as well. Okay? Now, should you see that written on there, you know that that is a butyl group. You cannot state this and say this is an isobutyl group or tertiary butyl group or secondary butyl group, because you need to see the structure for that. Okay? So what I mean by that is the first derivative we learned was methyl, then ethyl. But if we see this, okay, well then we know that that is a propyl group, C3H7, okay? But notice you have to see the structure if it's this derivative then. Okay? Yeah, that's still C3H7, but you can't say that this is a propyl group. You have to see the structure. Okay? But that's not always how it's written. Okay? Sometimes you've noticed it's written like this. This could be a condensed formula for an isopropyl group. Okay. So with that, are we comfortable? If you have no questions or concerns or anything to that effect, the rest of the time then will be yours. So left side, right side. Okay. So if we're good, you've got just over 20 minutes to utilize how you see fit. All right. Very good.